interestingly, Jeff covered a lot of stuff about SoftSim and took away a lot of what we could be saying. Oh, really? I need to talk louder?
Yes. Okay.
Yes. Interestingly, Jeff said a lot about SoftSim, and so we have less to say now, but fortunately, we have very little time. We've got about 5 minutes, so John, what are we going to say?
This is the upcoming release of SoftSim. It's not what you'll find on the web today.
Right. This is much nicer. We didn't want to show I didn't want to show the old one because I'm sick of it, and this one is way, way, way better. And also, it puts some pressure on us to release it, so I was hoping. So we'll see about that. There are a few things that we showed in the that Jeff showed in the demo, like the tick when he looked up a word. That's got to go into the compiler. One thing Jeff didn't mention, I'd like to mention quickly, is breakpoints. The new version has breakpoints. Hang on a second. 840 edit. I better find one. I better type slowly so I can do this fast. Okay, right. The MD5 application that I don't have time to talk about today has a breakpoint. Oh, I'm pointing on here and you can't see it. Huh?
Just say at the cursor.
Right there, where the cursor is. If you just put a yellow break in your source code, the compiler will remember what the value was of the interpreter pointer and the slot number, and pass that on to SoftSim. So SoftSim will know when to stop when the program hits. Oh, also the node. It remembers what node, what interpreter pointer, and what slot, so it knows where to break. I'm going to go to the load screen for the compiler, and instead of loading the, instead of loading that demo that I was just showing, this will load the MD5 demo. And let me see, I'll make sure we can actually see it. You can go fast. So, the MD5 demo, it runs up to about 28,000 steps, which you can see right in there. Okay, node 103 has reached the breakpoint. You see it's got a little bit of a gray box around it. That guy right there.
That's got X on it, I guess.
Yep. Well, that's a coincidence. The yellow X means it's got some of the focus. That means that this guy is a close-up of that node. This is the yellow. Red means 406 is the other one. But we've reached the breakpoint. It stopped, and the color change lets you figure out exactly which node it was that stopped. And we can just step a little bit further and run it, let it run again. When it finally reaches that point again, it'll break. This is, to do the MD5 application, I needed breakpoints because it was the only way I could figure out where bugs were happening. So we don't have breakpoints in the current SoftSim that's out there, so I just wanted to point out when the new one comes up, breakpoints are really handy. What's next?
The SoftSim is a programmer's tool. It has a whole bunch of features. It may not have exactly what you want. It's organized in a way that I hope that you'll be able to add stuff that you want. It's loaded here. You see the series of blocks. And the engine itself is what runs the ticks, runs the stuff. The opcodes, you can change opcodes, experiment with new opcodes. The actual implementation of what data gets moved around, what happens when an opcode executes, is independent of the engine that is causing this thing to run. On top of that, the display, what you choose to display and how you choose to display it is, again, independent of what goes underneath. So you can see from what this version looked like compared to the earlier one that Jeff showed, and the one anybody that's used it has seen. It's quite a bit different. The same with the keyboard. There's some weird keys on this one that aren't going to be there in the final release, I don't believe. But that's it. We're setting up test beds, setting up so that the interface from SoftSim is a voltage on a pin. How many millivolts is on the pin? The software that is simulating your device, the stuff that's outside, that's connected to that pin, has to recognize a voltage or generate a voltage. The simulator then determines whether that's a 0 or 1 as an input. And it sets the voltage based for an output depending on whether you've got a 0 or 1 inside the chip. That'll let you move your device between different processors, different chips that may have different I/O characteristics on the pins. That's all I've got to say.
Good enough? Sam?
It does not yet do analog or SerDes. That may or may not be in this release, but hey, you'll get the model of what's there. You're a programmer. Try it. Yeah.
Exactly. In the long run, we have plans for hooking up multiple instances to simulators.
Yes.
Right.
This is what I-
A little bit longer range plans include being able to communicate between not only different instances on one machine, but on multiple machines in multiple locations. Masa.
Do you have to use Cloudforce to program TA144?
Yes.
Right this minute you do.
And
But
foreseeable
we've given
future.
enough information out there. If you want to figure out your own way to do
Yeah.
it, you're welcome to.
Honestly, it's just
Yeah.
that they're not rich.
Right.
We're not rich. We're going to do it the simplest way.
Yeah.
Sam?
The other question that I have is this software available not just for Windows, but also for Linux or Mac OS?
It's running on Linux right now. Yeah, it works on
This is a Linux machine.
Yeah, yeah.
Runs under Wine.
Oh, yes, yes. Oh, it runs, okay, good.
Okay?
And parallels, but
Yeah, in parallel.
And
so-
parallels.
Question, i386 and x86-64?
What?
Jeff says yes.
64-bit,
Oh,
Jeff says yes.
this is a 64-bit.
64.
Yeah, I'm running.
good.
I'm running 32-bit Linux on a 64, so I don't know.
What if you're running a 64-bit Linux?
When it's announced, when you see the announcement about the new release, try it.
Yeah.
Sure.
Wait, do you have a 64-bit Linux? I can. We'll just send you this thing.
But I also
Yeah.
have an i386 I run version.
See, I don't know those answers. Sorry.
Well,
Yeah. We'll figure it out.
How do you tell us that?
Yeah. Or bring your machine to a meeting. Yeah.
Yes.
You want to just go ahead?
No, I want to switch over.
Greg suggested I.
Yeah, I know he did, but